Hello and welcome back to SciTi Tech. In this video, I'm going to show you how to make a very simple POV LED light show with using a Tip122 Transistor and some auto-changing RGB LEDs. Let's get started. And these are the items you're going to need to make for this project. The items you're going to need: a 9-volt battery, a Perfboard, a 9-volt battery clip, a 10k ohm potentiometer, a 1N4007 rectifier diode, a slide switch, a Tip122 transistor which can control the speed of this DC motor. And these are also the items that you're going to need to make for this project. This right here is a second circuit, and the items that you'll need in this circuit is a Perfboard, a slide switch, a 3-volt button cell battery, a 3-volt button cell battery holder, and 4 auto-changing RGB LEDs. And this right here is a schematic that you need to follow to make the speed motor controlling circuit. Now let's go ahead and assemble this project and let's get started. First, I have my Perfboard ready, and I have the 10k ohm potentiometer, and as you can see, there are no leads on this potentiometer. I have a very simple trick to fix this problem. All I have to do is take the potentiometer, place it onto the Perfboard, and as you can see, there are 3 holes of the potentiometer. Align these holes on the Perfboard, just like this. And now take a bridge wire or a lead from an LED, place it through the hole all the way through so that way it goes through the potentiometer and the Perfboard. Bend over the lead so it stays in place. Clamp it down. Add a little bit of solder so that way the lead will stay in place. Cut off the excess. And now turn it over and solder it into place. And there, you got 1 lead soldered into place. Now repeat the same process 2 more times. And there, should look just like this, and as you can see, it's nice and strong, soldered into place, and it stays in permanently. I only have one issue, and as you can see, the center pin of the potentiometer is touching the main housing of the potentiometer. This actually creates a short circuit, so what I need to do is insulate that. But I'll show you that later. Next, take the Tip122 transistor, take it and place it into the Perfboard. Right here is a good spot. Next, bend the base lead of the transistor over to the center pin of the potentiometer. And then bend the collector lead of the transistor over to the second pin of the potentiometer. In this case, it's the lead on the right. And now bend over the 2 leads of the potentiometer over to the base and collector of the transistor. And now solder everything into place. And then solder bridge the base over to the center pin of the potentiometer and the collector over to the other pin of the potentiometer. There we go, solder bridge just like this. Next, I want to take the rectifier diode. This side's negative, this side's positive, and the negative lead of the diode goes over to the free lead of the potentiometer. And then the positive lead will be just free. And I will connect that later. Bend the leads over like this. Make sure the negative is touching the potentiometer. Place it in just like this, and now bend the negative of the diode over to the free lead of the potentiometer. In this case, it's the left lead of the potentiometer. And now solder it into place. And now solder bridge the potentiometer over to the negative of the diode. And there, solder bridge just like this. Next, bend the lead of the emitter of the transistor in the opposite direction. Next, take the 9-volt battery clip. Take the positive wire of the 9-volt battery clip, and connect it to the collector of the transistor. Place the positive wire right here to make it easier to solder bridge it over to the collector of the transistor. Bend over the lead. Solder it into place, and then solder bridge it over to the collector. Next, take the 9-volt battery clip, and I want to take the negative wire, place it right here onto the Perfboard. Bend over the lead and solder bridge it over to the negative of the diode. Next, I want to connect the DC motor to the circuit. I want to take the positive wire, although polarity doesn't matter, but I'll still follow the positive wire. The positive wire will go over to the emitter of the transistor, place it in just like this, clamp it down, bend over the lead over to the emitter, solder it into place, and solder bridge it over to the emitter. Next, take the negative wire from the DC motor and connect it to the positive of the diode. Clamp it down, bend over the lead, and solder bridge it to the positive of the diode. And now cut off the excess, and there, the circuit is almost complete. Take the 9-volt battery, plug it in, test it out, and as you can see, it works. Turn the knob of the potentiometer, and as you can see, the speed of the DC motor changes. Starts to spin. Increase potentiometer, and it will spin faster. As I said earlier, I needed to insulate the potentiometer from the center pin of the potentiometer. Place a little bit of superglue in the center by bending over the potentiometer a little bit. Quickly cure the glue with some kicker. Wait for it to cure. And I'll apply some more glue and cure it. Press down on the glue and make sure it stays in place. And now taking a look at this, you can see that the DC motor spins a lot better. I have better control. Before it wasn't working so well, and now it works perfectly. As I turn the knob of the potentiometer, you can see the speed of the DC motor changes perfectly. Next, I'm going to take some cardboard and build the housing of the device. Take these pieces of cardboard and connect it to this device. Place a little bit of hot glue on the DC motor, and then take the piece of cardboard and glue it into place. And I repeat the same process on 3 more sides. And there, she'll look just like this. Take the wire and place it in between the cardboard. And now I want to take the DC motor housing and place it on top of this piece of cardboard. Enough space to be able to put the circuit and battery in place. Next, take some hot glue and glue everything into place. Test it out again, and I want to take the 9-volt battery, put it into place. And as you can see, the DC motor still spins. Very nice. And now it's time to create the second circuit. Next, I want to take the perf board, and I want to figure out where the center is on the perf board by simply counting the dots. And I want to be able to place it onto the DC motor. This right here is the center. By simply counting the dots, it brings me to this point. Next, I want to take the screwdriver and make a slight pilot hole onto this perf board. And now drill out the hole a little bit bigger. And I'll take it and place it onto the DC motor, and as you can see, it's a very tight fit, which is exactly what I want. There we go, make sure it's nice and balanced and level. Plug in the 9-volt battery and test it out and see how it looks. And there, as you can see, it works very well. It vibrates a little bit, but not too much. And it stays in place very well. Very nice. And now it's time to take the perf board again and add some components to the perf board. Take the 3-volt button cell battery holder, this side's a positive, this side's a negative, and I want to place it onto the perf board. Trying to be very careful to make sure it stays centered, so that way everything is properly balanced. Place it in, and now solder it into place. Next, I want to take the auto-changing RGB LEDs and place it into the perf board. I want to place 2 on each side, 2 here and 2 over here. The longer lead is the anode and the shorter lead is the cathode. And now simply take the LEDs and place them into the perf board, carefully. And now slightly solder it in place so that way it stays in. Put a little solder on one of the leads and then press down on the LED to make sure it's flush with the board, and then remelt the solder so that way the LED is more flush with the board. And now solder the LEDs into place. Next, I'm going to take a bridge wire and connect all of the cathodes of the LEDs over to the negative terminal of the 3-volt button cell battery holder. Next, bend the anode lead of the LED over to the positive terminal of the 3-volt button cell battery holder. And I'll take another bridge wire and solder the positive terminal of the 3-volt button cell battery holder over to the anode of the LED. Solder it into place, and now take another bridge wire. I'm going to place it over here to these two cathodes, connecting these two cathodes together. Solder them into place. And I'll take another bridge wire to the negative terminal of the 3-volt button cell battery holder, and now connecting all the cathodes together. And there, the cathodes are now grounded. And now repeat the same process with all of the anodes. Take a bridge wire, connecting those two anodes together. And then another bridge wire over to the positive terminal of the 3-volt button cell battery holder. And there, all of the anodes are now connected to the positive terminal of the 3-volt button cell battery holder. And now go test it out by taking a 3-volt button cell battery to complete the circuit. And there, the circuit is now complete, and as you can see, it works. Very nice. Next, take a little bit of super glue and put it on the shaft of the DC motor. And place a little bit of glue on the circuit of the LEDs. Making sure that everything is well saturated, so that way everything holds into place nice and strong. And now take the LED circuit and place it onto the shaft of the DC motor. Place it on nice and firm. Make sure it's perfectly balanced. Spray some activator. Add some more super glue onto the shaft. Put it all the way around to make sure there's a lot of glue. To make it extra strong, spray some activator, and there, it is now glued into place. Next, I'm going to take the 9-volt battery, connect it to the 9-volt battery clip. Place it right here, and now take the 3-volt button cell battery and place it into the 3-volt button cell battery holder. The LEDs light up, and now all I have to do is turn the potentiometer, and the LEDs will spin. And there, as you can see, it works. Although it vibrates quite a lot. That's because there's not a proper balance. That's a little bit of a problem because now when it vibrates, it moves. Although I don't like that it moves. That's an issue, so what I need to do is put something heavy on the bottom to prevent it from moving. But let's see how this looks in the dark before I do that. The LEDs light up, and when it spins, it creates a unique pattern. This looks very nice, very mesmerizing, and very interesting to look at. This brick right here is a very good solution to prevent this device from moving around and vibrating too much. Placing it on will prevent it from moving around like crazy and vibrating like crazy. Next, take a generous amount of hot glue and place it all over the brick. Place enough where it's the approximate size of the device. Put the device on the glue and move it around a little bit so that way it spreads around well. Add some more hot glue all the way around the edges to secure it in place even better. And there, the project is now complete and it should look just like this. And now let's go ahead and test it out again. And there, as you can see, this works a lot better. And now let's see how this looks in the dark. And as you can see, this still looks amazing in the dark. And there you have it. Now you know how to make a very simple POV LED light show with using a Tip122 Transistor and some auto-changing RGB LEDs. Thank you for watching SciTech Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified of future SciTech Tech videos. To the next tech, goodbye.